ellipse. The next conic which we're going to discuss here is ellipse. As we have seen that ellipse is the conic section of a cone when cut other than 90 degrees. As we have seen in the previous case that a cone which has the height and the radius is cut slantingly or sliced slantingly, we get an ellipse. That's how this is cut, and we get this conic section, which is an ellipse. So when this is cut other than 90 degrees to the height of the cone, we get slantingly the area of cross section, which is an ellipse. So the cross section gives us the conic section ellipse. So we're going to study in this topic about the various topics of ellipse or the property. Now that we have discussed about the ellipse related to eccentricity, let's recap with the ellipse. The ellipse, which generally looks in the shape of egg-shaped structure, with this being x-axis and this being y-axis, we have the focus and the point P, which is given by SP. Now I have a directrix which is a fixed line for the fixed point S. This. Now we have the definition of ellipse, which is generated from the fixed point S and a fixed line L, which is called the directrix, and this which is called the focus. The fixed point S and the fixed line L generate the ellipse, provided that SP by PM, which is denoted with eccentricity E, is less than 1. That's how we define the ellipse. If SP by PM is less than 1, we call this as an ellipse, where S is the fixed point and this is the fixed line, the directrix L. So SP by PM is less than 1, or SP less than PM equal to E is how we define the ellipse. Now let's see equation of ellipse in standard form. As we have equation of ellipse in standard form, which we're going to discuss here. Now we know that an ellipse is generally an oval shaped structure on this form, which is exactly symmetric about x-axis and y-axis. This is exactly in the center, where this is origin and this is the focus and this is the point on the ellipse, and this is the directrix L, and this is joined by SP and PM, and this is the point of intersection of the axis and the directrix. So Z is foot of perpendicular from focus to the directrix, and this is the vertex of the parabola of the ellipse, or this is where the center of ellipse, and I have A dash, and this is B dash. Now corresponding to this focus, I have a focus on the left which is S dash, which is image or reflection of S with respect to y-axis. Now this is the directrix L dash to the respect to point P dash connected with PM dash, and this with Z dash is how we define the ellipse with all its properties. Is how we get the whole of ellipse with each of them defined in this way. So here S and S dash are called foci of the ellipse. The plural of focus is foci, and then are called directrix, and then I have S dash and L dash, and C, which is center of ellipse, is how I understand each of the structures or the properties of the ellipse in standard form. Now, what is the equation of ellipse in standard form is what we're going to discuss in the session continued. Now let's see what are the coordinates of each of C, S, S dash, Z, Z dash, A dash, B dash, etc. So we'll see each of the coordinates and then define the equation of standard form of ellipse. So we know that the center is in the origin, so the coordinates of C are 0, 0, and the focus on the right is given by the coordinates AE, 0. And the coordinates of S dash are minus AE, 0, because it is exactly on the left, and this distance equals this. On the negative side, this will be minus AE, 0. And the coordinates of A are A0, and the coordinates of A dash are minus A0. And the coordinates of B are 0B, and the coordinates of B dash is 0 minus B, because it's on the down. So this makes me understand that CA is A and CA dash is also A, that is negative side of A, and CB is B and CB dash also is B, as I can see. So this is A and this is A, so AA dash will be 2A. And BB dash will be 2B, as we can see here. Now clearly I see that this is greater than this because this is flattened and this is bulged. So AA dash, in this case, the condition is that AA dash is greater than BB dash. That implies 2A is greater than 2B. That implies A must be greater than B. So for this kind of an ellipse, A must be greater than B is how we understand. So A is greater than B, as can be clearly seen in the diagram, where this is larger than this distance out here. So A greater than B for this ellipse. The focus, the center, and A is given, and the coordinates of the foot of perpendicular from focus to the directrix, which is Z. Z is the foot of perpendicular from focus to the directrix, and Z dash is the foot of perpendicular from focus S dash to the directrix L dash is what we see here. So the coordinates of Z are given to be a by e, comma 0, and the coordinates of Z dash are given to be minus a by e, comma 0. And we know that equation of this axis is y equal to 0, and the equation of this axis is x equal to 0. Now this is called major axis because it has the major segment of the ellipse, and this is called the minor axis because this has the minor segment of the ellipse. So this is the major axis, and this is the minor axis because this has the major segment along x-axis and minor segment along y-axis. Now with this, we are going to define the whole of the equation of ellipse in standard form.